as you recall, we added, if we go back to the Solution Explorer, we added a second implementation file named string.cpp. I'll double click this file and move it to another document tab group. So we're seeing all of our source files. And of course, we would, just like we're planning to use string in our main function, likewise, because we're going to provide the definitions of functions, we're going to include string.h in the implementation of our string file. Okay, so then we simply copy and paste declarations of all functions, including constructor. So I normally highlight this and use Shift Tab to align the white space indentation. Very important is to remove these semicolons from these declarations, because they're no longer going to be declarations. They're all going to be function definitions. So they all need the body of the function. So we can copy and paste these things. Okay, so now we have the bodies of the function. Now we also need to specify that these functions belong to class string. So there's a scope resolution operator that works like this. This colon is a scope resolution operator, which explains to the compiler that string, which is the name of the function, in our case it's a constructor of string class, and this constructor of course belongs to the scope of class string. Okay, so this is the name of the class and this is the name of the function. Likewise, copy this, and in front of every function name, such as length and character add, in front of these, we copy and paste this scope of class string. So now compiler understands that length is a member function of string, and it already knows from this include that this, of course, is a class, which is a user-defined data type. And once we have our user-defined data type, we can use it as a data type to create objects like this hello object. Okay, so how can we provide implementation of these functions? Well, let's start with constructor. So constructor responsibility is to populate this data member, because if you think about our current situation, that when we create the string hello, this creates an object named hello, and this object is like an object in memory. I like to draw my objects as boxes. And inside this box, there is this data member named pointer to string. And of course, as soon as compiler sees the string literal, it allocates these characters somewhere in constant memory, in read-only memory. And they will be constant characters. And of course, this pointer to string, which is this, is initialized or needs to be initialized to point to the first character in this block of memory. So to do this, we have a constructor. So constructor has to create this connection. And constructor is given pointer to this character already. It's right here. So this pointer to string is a parameter of our constructor, which is a pointer to this string of characters. So all we need to do is just copy its value, right? So just draw like a straight as I can line like this. Copy this over here. Okay. So we need to store this parameter inside of our object. So how do we do this? Well, in this case, we could use something that's called constructor initializer list. Okay, and it simply begins with a colon, not semicolon, but a colon symbol. And then we use this name, and then we can use this universal initializer and populate this with this. So this will construct properly, construct and populate this data member and store this pointer in here. Okay, because what we have is this PTR string is this. Okay, so it's the name of this data member right here. So I'll just draw a box around it. Okay, and this PTR string, it's the same name but different thing. It's a parameter. So this parameter is this. Okay, so this parameter, which has the same name, populates the data member of our class string with the pointer. And finally, as a result, of course, this pointer will be now pointing to the beginning of our string. So just a little bit of plumbing work. But constructor initializer list is very nice. It's very simple idea. Basically say, what is your data member? Okay, this is my data member. What is your parameter? This is my parameter. So now we combine them in the syntax and this gets initialized. And now we have something very nicely initialized. And that's the syntax. Okay, operations. So what kind of operations we need? So we can write some code here. We can say, for instance, return, and we can return strlen, which is a C library function that measures the sizes of zero-terminated strings, such as hello world. So for now, we can use that, and of course, its parameter will be our string pointer. Okay, so we'll see how this compiles and runs, except that strlen, of course, needs to be brought from the standard library header, and I will use, I can use it right here in this implementation file, include C string. Okay. All right, so let's also define our character at, which is supposed to return the character. So once again, we have this pointer to our characters, so we can just say return pointer to string and immediately use index to dereference this pointer and retrieve whatever character was required. So we're going to retrieve character H. So we should print the length of the string, and then we should print character H returned by char at. So let's save everything and build our program. Okay, so it builds quite nicely. Apparently everything is in place, and now it's time to run it. I press Ctrl F5, and you can see that apparently the length of this string is 13 characters long. We can measure the string, make sure that it's 13. We'll verify it in a second. And of course it returns the character H, which is the character at position 0. So every time I need to work with strings and other types that require some sort of indexing, sometimes it's helpful to add a comment with a ruler like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then again 0, 1, 2, 3. So this, of course, is 10, 11, 12, and 13, and so forth. So a little ruler like this helps. of course. And you can see that the position of the exclamation point is position 12, but because we're starting our count from 0, of course, the entire length of these positions is 13. So we're printing correct information here.